Now for this video, we're going to be looking at solving these nonlinear systems algebraically. And so we're going to do that through substitution. So I see here that I have y equals x squared minus 6x plus 3, and I have y equals negative 2x plus 3. And so I see that they're both equal to y. And so since they're both equal to y, I can actually set these equal to each other. And so I get x squared minus 6x plus 3 is equal to negative 2x plus 3. And now from here, I'm going to treat this just like what we've been doing all unit when we're solving quadratics. So my first step is to move all of my terms on the left-hand side. So I'm going to add 2x and subtract 3, add 2x and subtract 3. And so I get x squared, negative 6x plus 2x, I get minus 4x. And these cancel, is equal to 0. And now when I see this x squared minus 4x, I see that that can be easily factored using the GCF. And that's because they both have a GCF of x. So I'm going to go ahead and divide x from both. And so I get x times x minus 4 is equal to 0. And now since I have this in factored form, I can go ahead and set both of these equal to 0 and solve. And so I have x equals 0, x minus 4 is equal to 0. So I have x equals 0 and x equals 4. So it's really tempting to say, okay, I found my values of x, I'm done. Well, we're not quite done yet. Because if you recall, in our other examples, we ended up with ordered pairs in our answers. So we need to find the ordered pair as well. Right now we have the first coordinate, we know what x is, but now we need to know what that coordinating y value is when x is 0 or x is 4. So to find out that value, we need to plug in 0 and 4 back into either one of these equations. So you could plug these into either one. I like to go ahead and use my linear one just because it's a little bit easier substituting in. So let's start with x equals 0. Okay, when x equals 0, we have that y is equal to negative 2 times 0 plus 3. Well, negative 2 times 0 is 0, 0 plus 3 is 3. And so that means that one of my answers is 0, 3. I'm just going to write that on the side here. And now I need to do the same thing when x equals 4. So then I have that y is equal to negative 2 times 4 plus 3. Negative 2 times 4, I get negative 8 plus 3, which is going to be negative 5. And so that means that my other point is 4, negative 5. And so those are my two solutions. So to summarize, to do this, you're going to set them equal to each other if they're both equal to y. Solve it just like we would when we're solving quadratics using any method you choose. And then you have to plug those back in to find your y value. Okay, let's try another one. So here I have y equals x squared plus 2x plus 4 and y equals x plus 10. So I see they're both equal to y, so that means I can set them equal to each other. And so I have x squared plus 2x plus 4 is equal to x plus 10. And now with any quadratics, I need to get all my terms on one side. So I'm going to subtract x and subtract 10. Again, I'm moving these terms to the other side because I want my x squared term to be positive. And so I have x squared plus x minus 6 is equal to 0. And now from here, you can choose to solve this any way. You could solve by factoring, you can solve with a quadratic formula, completing the square, whatever way you prefer. I'm going to go ahead and do by factoring because I know this one's factorable. And so since this one, my a is equal to 1, I'm looking for two terms that multiply to negative 6 and add to equal to 1. So since I'm adding to a positive number, my smaller number needs to be negative, so I have negative 1 and 6. negative 2, and 3. And I see that negative 2 plus 3 equals 1. And so since I can use a shortcut since a is equal to 1, that means that this ends up being factored out to x minus 2 times x plus 3 is equal to 0. And now I can go ahead and set each of these factors equal to 0 and solve. And so I have x minus 2 is equal to 0, or x plus 3 is equal to 0. Well, add 2 to both sides, and I get that x is equal to 2. Subtract 3, and I get x is equal to negative 3. And again, remember, I'm not quite done yet. I have my x coordinate, but now I need to find my y. So I need to plug these values of x in to find out what my y equals at that point. And so I'm going to use my linear equation. And so I have that y is equal to x plus 10, so 2 plus 10, to get 12. And then when I plug in x equals negative 3, I have that y is equal to negative 3 plus 10, which is equal to 7. So that means that my 2 points are 2, 12, which I get from my first group here, and negative 3, 7. Okay, let's look at one last one. So here we're going to start with that same step. Since they're both equal to y, I'm going to set them equal to one another. So I have x squared minus 3x minus 7 is equal to negative 3x minus 10. I want to get all of my terms on one side, so I get plus 3x plus 10 and so I have x squared. My x term actually cancels out here, and then negative 7 plus 10, I get 3. And now since I don't have that x term, I can solve this with square roots. So I'm going to subtract 3 from both sides, and I get x squared is equal to negative 3. And then I'm going to take the square root. However, I see I have a problem here. I'm trying to take a square root of a negative number. And remember, this can't be negative when we're taking it. And we learned that from the discriminant, when it's less than 0, that means there's no real solutions. And we saw that again when we're using the quadratic formula. So since I'm trying to take the square root of a negative number here, that means that this system has no solution. So if I were to graph this, I would see that that line and that parabola never intersect.